Good morning everyone. Today we will discuss about alcohol. The species which are formed by the replacement of one or more than one hydrogen atom from the aliphatic hydrocarbon or from the side chain of aromatic hydrocarbon by hydroxy group. Methane, when we replace H with OH group, it converted into methanol. Example, toluene into benzoyl chloride. Phenols, the species which are formed by the replacement of one or more hydrogen atom of a benzene ring by hydroxy group. Example, benzene to phenol. Phenols, the species which are formed by the replacement of one or more hydrogen atom of benzene ring by any group in phenols. For example, phenols into halophenols. Classification of alcohol. The alcohol are classified in different ways as first way of classification. First, aliphatic alcohols, the alcohols which are formed by the replacement of one or more hydrogen from aliphatic hydrocarbon by hydroxy group. For example, methane into methanol. Aromatic alcohols, the alcohols which are formed by the replacement of one or more hydrogen atom from the side chain of aromatic hydrocarbon by hydroxy group. For example, toluene to benzoyl alcohol. Note: the species which contain more than one OH group on the same hydrocarbon are unstable and they get stabilized by the loss of a water molecule. Hence, we can say that one carbon atom can have maximum of one OH group. For example, in this example, there will be two OH group in the same carbon. Therefore, it lost water from its molecules. It converted into aldehyde. Second way of classification: monohydric alcohol, dihydric, trihydric alcohols. Monohydric alcohols, the alcohol which contain only one hydroxy group. Dihydric alcohol, the alcohol which contain two hydroxy group. Trihydric alcohols, the alcohol which are contain three OH group. For example of a monohydric alcohol, ethanol. Example of a dihydric alcohols, ethane 1,2-diol या glycol, ethylene glycol. Trihydric alcohol, propane 1,2,3-triol या glycol. Type of monohydric alcohol, they can be followed type as primary, secondary, tertiary. Primary alcohol, the alcohol in which the carbon contained OH group is further linked either with one or no carbon atom. Example, ethanol. Secondary alcohol, the alcohol in which the carbon containing OH group is further linked with two more carbon atom. For example, propane 2-ol. Tertiary alcohol, the alcohol in which the carbon containing OH group links with three more carbon atom. For example, 2-methyl prop 2-ol. Type of functional group. Functional group, secondary suffix and secondary prefix. For carboxylic acid, we use functional group C double bond OOH. 2 degree suffix for carboxylic acid, oic acid. 2 degree suffix for prefix for carboxylic acid, carboxy. For sulfonic acid, SO3H is the functional group. Sulfonic acid, secondary suffix, sulfo, secondary prefix. Acid anhydride, functional group C double bond O, C double bond O, R. Oic anhydride is the secondary suffix. There is no secondary prefix for acid anhydride. Ester, functional group for ester, C double bond O, R. OH is a secondary suffix and carb alkoxy is the secondary prefix. Acid chloride, C double bond O, Cl is a functional group for acid chloride. Oil chloride is secondary suffix and chloroalkanols are a secondary prefix. Acid amides. C double bond O NH2 is a functional group. Amide 2-degree suffix. Amyl 2-degree prefix. And there are some other group naming functional group and 2-degree suffix and prefix for other groups like ketones, alcohol, phenol, amine, ethers, nitriles, etc. Secondary prefix. It tell about the nature and position of the substituent 2-degree functional group. Primary suffix. It tell whether the compound is a cyclic or acyclic. Word root. It tell about number of carbon atom in the principal chain. Primary suffix. It tell about principal chain is saturated or unsaturated. Secondary suffix. It tell about the nature of the position of the primary functional group. Like we named this compound. Here we count the carbons 1, 2, 3. Here are 2 methyls in carbon number 2. So we write 2,2-dimethyl. And there is a 3 carbon in a cyclic chain. So cyclopropane oil. For OH group we use ol. Now we will name this compound. There is the functional group in side chain. So we this is a secondary prefix. So we name like 1-phenyl propane 1, 2, 3 prop. There is a this is the saturated compound. So we use N. There is a hydroxy group in second carbon. So we use 2-ol. In this compound, C double carboxylic acid is a primary 1-degree functional group and OH is a 2nd-degree functional group. So we named as 2,2-hydroxypropyl benzoic acid. IUPAC naming of aromatic hydrocarbon. Rule number 1. If an aromatic compound has only one functional group, then this common name and IUPAC name will be same. Like benzene. If we remove hydrogen from benzene, this is known as phenyl. If we remove 2 hydrogen from benzene, this is known as aryl. If we replace H group of hydrogen atom of benzene by OH, this is known as phenol. If we remove hydrogen atom of benzene by CH3, this is known as toluene. If we remove H atom by CH2 and dash, this is known as benzyl. Second rule. If an aromatic compound has more than one functional group on a nucleus part, then given the lowest number to 1-degree primary functional group. Aromatic hydrocarbon. An aromatic compound containing 2 parts, nucleus or side chain. Aromatic compound can be following 2 types: nucleus substituent compound or side chain substituent compound. Nucleus substituted compound, the compound in which the functional group is directly attached to a benzene ring, like this. Side chain substitution compound, the compound in which the functional group is present in a side chain. For example, in this, the functional group is attached with side chain carbon CH2OH. This is nucleus part, this is side chain. Type of nucleus substitution compound. Ortho, the compound in which the substituents are present on a carbon 2 or carbon 6 position with respect to primary functional group, called ortho substituted compound. Like there 2, 1, 2, 3, 4, 5, 6. If we join any group with 2 and 6, this is known as ortho substituted compounds. Meta, the compound in which the substitutions are present on carbon 3 and carbon 5 position with respect to primary functional group is called meta substituted compounds. Like if we attached any group with in position 3 and 5, this is known as meta substituted compound. Para, the compound in which the substituent are present on the carbon 4 position with respect to primary functional group. This is known as para substituted compound. Physical properties of alcohol. Nature of a bonding between molecules. There is hydrogen bonding between alcohol, like one H is there is intermolecular hydrogen between H and O in other one and other molecule of alcohols. Condition for hydrogen bonding: presence of hydrogen atom and H must attach with more electronegative fluorine, oxygen and nitrogen atom. Association: due to the presence of intermolecular hydrogen bonding of alcohol molecules, they show molecular association for gained molecules. State of solubility: there is intermolecular hydrogen bonding in alcohol, so they exist in a liquid state. Viscosity: they have high viscosity and than hydrocarbon, alkyl halide, ester as comparable molecular mass due to the presence of intermolecular hydrogen bonding. Boiling point: more heat is required to break the primary hydrogen carbon present between the alcohol molecules, so they have high boiling point than hydrocarbon, alkyl halide, ethers of a comparable molecular mass. Solubility: due to the presence of intermolecular hydrogen bonding between the alcohols and H2O molecule, they are soluble in water. Acidity: due to the loss of H positive hydrogen atom as H positive ion in aqueous get stabilized. Comparison of viscosity and boiling point of a glycol, ethylene glycol, glycerol, ethylene glycol, monohydric alcohols. Magnitude of viscosity of a boiling point depend upon the extent of intermolecular hydrogen bonding between the molecule. Due to the presence of a number of OH group in glycerol molecules, 3 OH group, ethylene glycol 2 OH group, then monohydric 1. In glycerol there is a 3 OH group, and they in this molecule there is extensive hydrogen bonding. More hydric alcohol, less heat, more heat is required. This is the more extensive intermolecular hydrogen bonding between glycol molecule, ethylene glycol molecule than in between monohydric alcohol. Hence the order of viscosity: glycerol, ethylene glycol, monohydric alcohol. More heat is required to break extensive hydrogen bonding in glycol, glycerol, ethylene glycol, then methylene glycol. Hence order of boiling point: glycerol, ethylene glycol, monohydric alcohol. Comparison of boiling point among isomeric primary, secondary, tertiary alcohol. Magnitude of viscosity and boiling point also depend upon extension of van der Waals force between the molecule. In 1 degree molecule, there is a more surface area, more van der Waals force, more heat. In 2 degree and 3 degree alcohol, less surface area, weak van der Waals force, less heat. On moving from 1 degree alcohol to 2 degree and 3 degree, branch increase and thus the surface area decrease. So magnitude of van der Waals force decrease, hence the amount of heat required to break van der Waals force also decrease. Therefore the boiling point of also decrease: 1 degree, 2 degree, then 3 degree. Comparison between among the homologous series of alcohol. On moving along the homologous series of alcohol, the surface area increase and the amount of heat required to break van der Waals force also increase. Hence boiling point also increase. For example, in methanol, there is a less surface area, so weak van der Waals force bond, then less heat is required to break the bond. In In butanols, there is a more surface area, strong van der Waals force than methanols, and more heat is required to break the bonds.